Okay, let's begin our lecture. Now we will have this new section, row echelon form. In this section, we will learn about what is row echelon form and Gaussian elimination, and also overdetermined system and underdetermined systems. And also we will consider about reduced row echelon form and also application. The first part, we consider what is row echelon form and what is Gaussian elimination. So what if at any stage all the possible choices for a pivot element in a given column are 0? So in this case, we cannot reduce it to triangular form, but we can reduce it to a special echelon form, a staircase-shaped form. After you transform the augmented matrix to echelon form, there may be two cases happens. Okay, the first one, there's no solution. So in this case, all zeros on the left, but non-zero on the right. So if it's like this, there's no solution to this linear system. Okay, and also, in sometimes you will find there are infinitely many solutions. So in this case, you will find 0 rows in the bottom. So now we see concrete examples. This augmented matrix. Okay. After we get this 5 by 5 matrix, okay, it's a 5 by 5 linear system. For example, the first row is just x1 plus x2 plus x3 plus x4 plus x5 equals 1. Okay. After we get this augmented matrix, we use row operations to transform it into simpler form. So the first row, we keep the same. We don't change this one because it is a pivotal row. And then we use this 1 entry here, 1 entry here, to eliminate this entry, 2 1 entry, and also this 2 2 entry, and also this 5 1 entry. This is 3 1 entry. Here is 2 1 entry to be 0. So in order to eliminate this one to be 0, we just use the first row add to the second row. Right? We'll get here it's 0 0 1 1 2 0. Okay, and in order to eliminate this 3 1 entry to be 0, we just use 2 times this first row and then add to the third row. So we will get here is 0 0 2 2 5 3. Okay, so again we can use minus 1 times the first row, then add to the last row. Okay, then we get this one. So after such operations, row operations, we get this augmented matrix. Now we find all the possible pivot elements are 0. So for this augmented matrix, we cannot transform it to triangular form, but we can transform it to simpler form as a row echelon form. Okay, so again we use this one, the 2 3 entry to be pivot element, and the second row to be the pivotal row. Okay? And we use this 2 3 entry to eliminate this 2 to be 0, this 1 to be 0, this 1 to be 0. Right? So we use minus 2 times the second row, then add to the third row. Okay, and we use minus 1 times the second row, then add to the fourth row, and also minus 1 times the second row, this pivotal row, to the last row, and we can get simpler form. So if we keep going on with the next few pivotal rows, we will reach at a staircase form. We will reach this form. Okay. See, For this augmented matrix, we found the last two rows. On the left side, they are zeros. However, the right-hand side is non-zero. So, for example, from this fourth row, you will get it as 0 times x1 plus 0 times x2 plus 0 times x3 plus 0 times x4 plus 0 times x5 equals -4. So there's no solution, right? How can you get the left side is 0, however, the right side is non-zero? So these two equations cannot be fulfilled. So after you transform this system to row echelon form, if you find eventually the left side all zeros here in the row and the right side is non-zero, okay, the system is inconsistent. Okay, if we drop in these two inconsistent constants, we can reach a new linear system. So we can see if we find this new linear system, so the solution set changes to be infinitely many solutions. Okay, after we do the row operations to this matrix, augmented matrix, we find this row echelon form. See, this row echelon form, the last two rows are all zeros here. Okay, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so this system, you can have lead variables. So x1 here, x3 here, and x5 here, they are lead variables. The variables corresponding to the first non-zero element of each row, we define it as lead variables. And all the other variables, for example, x2, and they are free variables. For free variables, you can assign arbitrary real number. So this linear system is consistent. We have infinitely many solutions for this linear system. Okay. Now, so what is a row echelon form? We give the definition here. A matrix is said to be in row echelon form if the first non-zero entry in each non-zero row is 1. We require this condition. And second, if row K doesn't consist entirely of zeros, the number of leading zero entries in row K plus 1 is greater than the number of leading zero entries in row K. And thirdly, if there are rows whose entries are all zero, they are below the rows being non-zero entries. So the third condition requires all the zero rows are in the bottom of the matrix. Okay, so we have this definition for row echelon form. The first non-zero entry in each non-zero row is 1, and for the number of zeros, they are increasing, right? So the number of leading zero entries in row K plus 1 is greater than the number of leading zeros in row K. Okay, and thirdly, all the zero rows, they are at the bottom. And using those procedures, in fact, we give the Gaussian elimination procedure. So the process of using row operations 1, 2, and 3 to transform a linear system into one whose augmented matrix is in row echelon form is called Gaussian elimination. So this is a very famous, very useful ways to solve linear system, Gaussian elimination. So this is the exercise. So you can see which of the following augmented matrices are in row echelon form. The first question. The second question, if it is not, using 3 types of row operations to get the row echelon form. Okay, the second question. The third question, solve the corresponding linear system. How about the first question, which of the following augmented matrices are in row echelon form? This one is in row echelon form or not? It is, right? It satisfies all the conditions, right? The first non-zero entry in each non-zero row is 1, right? And the number of leading zeros, they are increasing. And all the zero rows, they are at the bottom, right? So it is in row echelon form. How about this one? This one also is in row echelon form. Okay, so each non-zero row, the first non-zero entry in each non-zero row is 1, and also the number of leading zeros, they are increasing along with the rows. Okay, and also the 0 row is at the bottom of this matrix, so it is also in row echelon form. And how about the third one? The third augmented matrix we can find is leading, the number of leading zeros decreases along the number, the rows. Okay, so this is not in row echelon form. So how to transform this to row echelon form? You can just use row operation 1. You change the 2 rows, right? You change the second row and the third row. You will transform this to row echelon form. After you get the row echelon form, then it's easy to get its solution. It's easy to solve this linear system.